In 1934, an RAF staff officer named Ralph Sorley sat down with Captain F.W. Hill and worked out exactly how long a fighter pilot would have to shoot down a modern bomber. The answer was roughly 2 seconds. 2 seconds of effective firing time in a deflection attack. Hill ran the numbers on what that meant in terms of weight of fire, and Sorley's conclusion drove an entire generation of British fighter design. You needed 8 guns, minimum. Not because 8 guns were ideal, because the individual round wasn't powerful enough, and multiplying rounds delivered per second was the only way to compensate. That compromise, 8 guns to paper over a calibre problem, was built into the RAF's next-generation fighter specification by 1935. The Air Ministry formally recognised that existing armament levels were insufficient and specified a replacement path: 8.303 machine guns, or 4 20mm cannons. They weren't declaring the .303 dead in official language, but they were writing its successor into the specification. The 5-year clock had started. 5 years later, the Battle of Britain began. RAF pilots were still firing. 303 rounds. And the squadron that had actually been given the cannon replacement, No. 19 Squadron at Duxford, flying cannon-armed Spitfire Mk I IBs, complained so persistently about the cannons that the aircraft were withdrawn and replaced by conventionally armed machines. Because the Hispano Mk I had jammed so catastrophically, so repeatedly, that the pilots preferred a bullet, the Air Ministry had effectively written off over the replacement that was supposed to save them. That is the story the triumphalist version skips entirely. The competitor's video spent considerable runtime on the inventor of DeWilder incendiary ammunition, his biography, his demonstration to the RAF, the human drama of a single bullet. 45 audience comments were analysed from that video. Not one mentioned either name with any enthusiasm. What they mentioned, repeatedly, was frustration. Frustration that a complex institutional failure had been reduced to a magic round. Frustration that the narrative implied one clever piece of ordnance had preserved liberal democracy. The top comment didn't debate the ballistics at all. It just rejected the premise outright. The premise deserves rejecting. But rejecting a bad explanation doesn't mean the real story is simple. The real story is considerably darker and more interesting than either version suggests. Start with what Sorley's calculation actually meant. 8 Browning .303s, each firing at 1,200 rounds per minute in aircraft-mounted configuration. 8 guns simultaneously, 9,600 rounds per minute, or 160 rounds every second. The Spitfire and Hurricane weren't delivering a sniper shot. They were delivering a sustained wall of fire for 2 seconds, concentrated by harmonization at a convergence point typically set at 250 yards. The guns' lines of fire converged there, producing the densest strike pattern at that distance. Beyond and before that point, the pattern spread. Pilots and armories sometimes set different convergence distances, 300 yards, 400 yards, depending on individual preference and doctrine. What this created wasn't the simplistic crosshair the competitor depicted, a single, precise point where everything lined up perfectly and the target evaporated. What it created was a dispersion zone, a spread pattern that was effective across a range of distances, with maximum density at the harmonization point. An area attack. The pilot didn't need to thread a needle. He needed to put the target into the buzzsaw. That distinction matters because it's what the 8-gun configuration was actually designed to do. Hill's calculation didn't assume perfect aim. It assumed a deflection shot, a moving target, a pilot under pressure, and it asked, given all that, how many rounds do you need to guarantee destruction? The answer was a high-density spread, not a precision beam. The .303's individual striking power was, as multiple contemporary sources noted, marginal against modern metal aircraft. Multiply it by 160 rounds per second, and you have something operationally viable. But only barely, and only against what was flying in 1940. The Sorley specification acknowledged this implicitly by offering an alternative: 4 20mm cannon. A single 20mm round carried dramatically greater kinetic energy and explosive effect than a .303 round, an order of magnitude more destructive potential per hit. 4 of them, firing simultaneously, didn't need to hit as many times. The trade-off was rate of fire. Cannon fired more slowly, but the destructive potential per round was in a different category. The Spitfire and Hurricane had been specified to carry cannon from the beginning. The question was why they didn't. 2 answers, and they compound each other. The first is production. In 1939, Birmingham Small Arms produced 432 Hispano cannons, the entire year. Fighter Command was operating hundreds of aircraft, each of which required 4 cannon for a full installation. Even at 1940's significantly increased output of 3,360 Hispano cannons across the full year, equipping the entire fighter fleet was arithmetically impossible. The bottleneck wasn't institutional cowardice, it was steel and machining time and supply chains that didn't exist at scale. This is the credible defense the prosecution is required to acknowledge. The RAF couldn't have rearmed Fighter Command with cannon in 1940, even if every bureaucrat involved had been a genius. The logistical gap was too wide, and it had been too wide for too long. The second answer is engineering, and this is where the 19 Squadron story stops being a detail and becomes the thesis. The Hispano Mk I had been designed to fire upright. Its 60-round drum feed relied on consistent orientation to work reliably. The Spitfire's wing was too thin, not inadequate by a small margin, genuinely insufficient to house the cannon in its designed position. The gun had to be canted, turned partly on its side, just to fit inside the wing profile. Even canted like that, external blisters had to be added to the wing surface to contain the breach. The result was a feed mechanism operating sideways, against the geometry it had been designed for, with the ammunition drum physically contacting wing surfaces during firing. Jamming wasn't a risk. Jamming was the expected operational outcome. No. 19 Squadron flew these aircraft in combat. The pilots complained repeatedly. After numerous complaints in the summer of 1940, the cannon-armed Spitfires were withdrawn and replaced by conventionally armed aircraft in September of that year. The squadron went back to .303s. The sources confirm the withdrawal and confirm the complaints. Whether the pilots submitted a formal documented petition isn't verified in the available record. What's confirmed is that repeated operational complaints produced an institutional response, which itself tells you something about how loud those complaints must have been. This is the moment the narrative inverts. The RAF had recognized the inadequacy of its standard armament in 1934. It had specified a cannon alternative in 1935. It had initiated a program to develop and deploy that alternative. And when the battle came, the alternative jammed on its side in a wing it didn't fit, and the pilots who flew with it chose the weapon that had been written off over the weapon that was supposed to replace it. The villain in this story isn't a cartoon bureaucrat sitting on a solution while pilots died. The villain is a system caught between a weapon it knew was dying and a replacement that literally didn't function. That's harder to prosecute, and it's also the truth. What partially bridged the gap was de-wheeled incendiary ammunition. The .303 de-wheeled round produced a small flash on impact, visible to the pilot, confirming strikes without a smoke trail that could obscure the target. Against fabric-covered aircraft it was effective. Against fuel tanks it was effective. It gave the 8 Browning pilots something the standard ball ammunition didn't: visual feedback and genuine incendiary potential against the most vulnerable areas of German aircraft. Tactically, it mattered. In the context of the broader armament problem, it was a patch on a known wound. The calibre wasn't changing. The round was still .303. De-wheeled made the .303 as useful as it was ever going to be in 1940, which was considerably better than useless, but it wasn't a solution to the problem Sorley and Hill had identified 6 years earlier. One further dimension of the harmonisation question has appeared in pilot accounts: the claim that only officers could request specific convergence settings from their armouries, with non-commissioned pilots flying whatever harmonisation had been set without the standing to demand a change. According to those accounts, this created a practical disparity in combat effectiveness between officer and NCO pilots that had nothing to do with skill or courage and everything to do with rank. The evidence stops short of confirming this as formal RAF policy. No official document in the available record establishes it as a written rule. But the accounts exist, and they fit the institutional culture of the period well enough that dismissing them entirely requires more certainty than the sources provide. Treat it as reported and unconfirmed, because that's what it is. What is confirmed completely is what actually kept Britain in the fight. Air Chief Marshal Sir Hugh Dowding had begun building his integrated air defence system from approximately 1936 onward. By the summer of 1940, it was operational in a form that had no equivalent anywhere on Earth. Chain-home radar stations along Britain's southeastern and eastern coasts could detect incoming aircraft at ranges up to 120 miles at high altitude. The radar data fed into a filtering and plotting network that ran through Bentley Priory, Fighter Command headquarters, down through group operations rooms and out to sector stations that had direct communication with airborne squadrons. The Observer Corps filled in the picture inland, tracking formations that radar had handed off at the coastline. The Germans knew the radar towers existed. They attacked them. On August 12, 1940, the Ventnor Chain Home Station was knocked out. Mobile Chain Home Low units restored coverage within days. The system had redundancy built in, because Dowding understood that no single component could be allowed to be a single point of failure. What this meant in practical operational terms was that Fighter Command didn't have to fly standing patrols, burning fuel and fatiguing pilots on the chance of intercepting a raid. They could scramble specific squadrons in response to specific threats, with the bearing, altitude and approximate strength of incoming formations already known before the British pilots were airborne. The Germans flew across the Channel without knowing whether interception was coming, or from where, or in what strength. The RAF flew knowing. That asymmetry, not any bullet type, was the structural advantage that made defence viable against an air force that outnumbered them in operational aircraft. The Dowding system's contribution to the battle's outcome isn't separable from the armament question. If the system had not existed, Fighter Command would have needed to compensate for German surprise with larger numbers of aircraft, maintained at higher readiness, burning through pilots and machines faster than any sustainable attrition rate allowed. The .303's limitations would have been magnified in a battle of brute force and numbers. With the system running, Fighter Command could concentrate force precisely, making each engagement as efficient as the available weapons allowed. The marginal calibre became manageable. The inadequate bullet became survivable. That's not a celebration. It's a structural argument about what actually compensated for what. The cannon solution came eventually. The Hispano Mk II incorporated a belt feeding system developed by Martin Baker, replacing the 60-round drum that had failed so catastrophically in No. 19 Squadron's wings. Augmented heating systems addressed the freezing at operational altitude that had been an additional failure mode of the Mk I. The RAF and Fleet Air Arm adopted the Mk II in 1941. The Spitfire Mk V, which carried the cannon reliably, entered service that same year. By then, the Battle of Britain had been over for months. The engineering wasn't solved because bureaucrats finally got around to it. The engineering was solved because Martin Baker designed a different feed system, and heating engineers addressed the altitude problem. The Mk I couldn't be fixed in its existing form. The institutional failure wasn't the delay in adopting a working solution. It was the gap between recognizing the problem in 1934 and having a solution ready by 1940, during which the only available cannon was one that wouldn't reliably fire in the airframe it was supposed to arm. A different production timeline, earlier investment, harder institutional pressure on the cannon program in 1936 or 1937 rather than 1941. These are the counterfactuals that haunt the record. Not because they change what happened, but because the men who flew with .303s deserved better than a calibre their own air ministry had written off before their aircraft were designed. The pilots of No. 19 Squadron flew a cannon that jammed and asked for their machine guns back. That's not a story about inadequate courage or insufficient technical sophistication. It's a story about flying into combat with the best available option. And the best available option was something everyone in the chain of command had known for half a decade wasn't good enough. Dowding's system made it survivable. The pilots made it work. The institution failed them, and survived on the grace of a radar network and a control architecture that had been built to compensate for exactly this kind of weapons inadequacy. The De Wilde incendiary round was a genuine tactical improvement. 8 Brownings firing 160 rounds per second at a 250-yard convergence created a dispersion pattern that German aircrew had real reason to fear, regardless of what calibre was producing it. None of that is false. All of that is also the best face on a situation the Air Ministry knew was substandard from the moment the specification was written. Britain won the Battle of Britain. The .303 didn't lose it, and the cannon failure didn't lose it, because Dowding had built a system good enough to absorb both problems simultaneously. That's not triumph. That's how close it actually was. The pilots who flew with .303s and the pilots who sent the cannons back weren't failed by their nerve. They were failed by an institution that had 6 years between recognizing the problem and fighting the battle, produced 432 cannon in the first of those 6 years, and handed pilots a replacement that had to be mounted on its side in a wing too thin to hold it upright. They flew with what they had. The system Dowding built did the rest. If you want more stories about what institutional decisions actually cost the people who had to live with them, subscribe. There's considerably more where this came from.